Hello and welcome to Math Matters. Why do I need to know this? It's a TV show where we take a look at the entry-level mathematics being taught in our general ed math courses and try to apply that to everyday life. I've got some cool stuff to show you today, and I want to make apologies to the 109 students, the general math students, because this is a more of an algebraic show. Last time we started talking about matrix multiplication and all the things you could do with that, and I gave one example of that, and I thought, man, I can think of so much more I can do with matrices and matrix multiplication. So I'm going to revisit that topic today for a couple of segments. I'd like to talk about how we can use matrix multiplication to calculate probabilities. This is a slightly different idea. And I have to go back and recoup a little bit of this introduction of what a matrix is. It's just a rectangular set of values. It's something along these lines. I'd call that a matrix. And we consider the number of rows, the first dimension of this, the number of columns, the second dimension, and we would call that a 3x4 matrix. We multiply matrices in this fashion. The middle dimension here, this dimension right here has to match up, and it will generate in this case, a 3x3 matrix in this fashion. It's messy, but I'll explain it. Looks bad. But here's what's happening. To get this first entry in the first row, first column, I look at the first row of the first matrix, first column of the second matrix, and I take those entries, multiply them, and add them up. So 3 times 1 plus 1 times 2, 1 times 2 gives me that entry. And then to get the next one right here, I take the first row, second column, and do the same stunt. To get this one, I take the second row, first column, and add those things up. And you just go through all 9 of those entries, and that's how you get the answer with matrix multiplication. Now, and we showed that in the last episode, but I want to recap that because I'm getting ready to use that trick again. And what I'd like to do is take a look at some very, very complicated probability situations and show you how all that stuff that's built into matrix multiplication just automatically takes care of issues for you. Okay? Now I'm going to throw a situation at you that's fairly contrived. But the way I'm going to solve it is I'm going to arrange probabilities in a matrix. So each of these would be probabilities. And I would consider this first entry the probability I go from one state back into that state. Okay, and I'm going to kind of think about different places I could be in my problem. The second entry here would be from the first state to the second state, first state to the other states, and then from the second state to the first one and so forth. I don't mean United States of America. I mean different places I could be in my problem. I'll give you an example, and it's a really contrived example, but it's an easy example, and that's what I want to show you first is how you could use this in an easy example, and then you can adapt that, if you'd like, to tougher situations. Let's take a look at this idea. I've got 3 people, Amy, Brad, and Carol, throwing a Frisbee to each other in the backyard. Now Amy shares the Frisbee equally with Brad and Carol, but Brad is kind of sweet on Carol, so he throws her the Frisbee about 90% of the time. And then Carol and Amy are buds, and Carol doesn't maybe think too much of Brad, so she will typically throw the Frisbee to Amy about 75% of the time. So now let me ask a very complicated question. If Brad is the first guy to hold the Frisbee, and they toss this thing around 12 times, what's the probability that each of these people will have the Frisbee after those 12 tosses? Okay? Now, there's a hard way and there's an easy way. The hard way would be, and I'm just going to look at 2 tosses. The hard way would be to list out all the different ways someone could end up with the Frisbee. And I've done this for 2 tosses. Brad starts, and he's going to throw it to either Amy or Carol. And then Amy is going to throw it to either Brad or Carol, and Carol's going to throw it to either Amy or Brad. Okay. You can put the probabilities on this tree diagram. That's what that's called, is a tree diagram. For example, Brad kind of likes Carol, so there's a 9/10 chance that he will throw the Frisbee to her. That means there's a 1 in 10 chance that he will throw it to Amy. Those have to add up to 1. And then with Amy, she shares the Frisbee equally, so 1/2 and 1/2. And then Carol 3/4 of the time will throw it to Amy. That means that 1/4 of the time she will throw it to Brad. So you can look then and calculate the probabilities for each of these paths. The chances that it happens in this fashion, Brad, Amy, Brad, would be the product of those probabilities, so about 1/20th. And the probability that it ends up in Carol's hands like this is 1/20th, and the probability ends up in Amy's hands in this fashion is 27/40ths. I'm multiplying things out here. And that it ends up in Brad's hands going through Carol would be 9/40ths. So the probability then, after 2 tosses, that Amy has it is just this one, 27/40ths. The probability Carol has it is just this one, 1/20th. And then Brad, you've got to take both of these into account and add them together to get 11/40ths. Okay? I'm sorry, I didn't mean to flash that away. So that would be the answer for 2 tosses. To do this for 12 tosses, you'd have to make your table that wide. You'd have to make a huge table. You'd have to have all these probabilities listed. You have to multiply them all out, then add them up when you have multiple things. It's horrible, okay? Now watch what I can do with a matrix. We create what's called a transition matrix, where I put the probabilities in. The probability that Amy throws to Amy is 0. She's not going to throw the Frisbee to herself, but she's going to divide it equally between Brad and Carol. So I'll put those probabilities in. Notice that the sum of those entries is 1 in that column. Brad will not throw the Frisbee to himself. There's a 9 in 10 chance he will throw it to Carol, and a 1 in 10 chance he'll throw to Amy. Notice again, the sum of the entries in that column are 1. Carol will not throw the Frisbee to herself. There's a 3/4 chance she will throw to Amy, and a 1/4 chance she'll throw it to Brad. The sum of those entries is 1. We call this a stochastic matrix, where all the entries are probabilities between 0 and 1, could be 0 or 1, and then the sum of the columns is 1. So to work the problem, well, after the first toss, what I would do is I would start with Brad holding the Frisbee. That means a 100% chance Brad has it, and just multiply. That gives me just really the middle column. It just strips that middle column out. There's a 1 in 10 chance that Amy has it, a 9 in 10 chance that Carol has it. After 2 tosses, well, I do this again, and really what I could do to get this matrix, I multiplied this times this, so I could square that one and do it that way, but I'll just go through, do the matrix multiplication, and that gives me the probabilities. The easy way, though, lies right here. To do this in so many tosses, I want to raise that matrix to a power. So to do this for 12 tosses, what I would do is I would put this matrix in my graphing calculator. I wouldn't do it by hand, that's horrible, but these graphing calculators can do this kind of stuff for you. And I would raise that matrix to a power, which is a fairly messy thing, you can see it here, but then multiply by that original thing. Brad had the Frisbee to start out with, and so there are my probabilities, this middle column. 33% chance Amy has the Frisbee, 27% chance Brad has it, 40% chance Carol has it. And the cool thing is, if you'll notice, each of these columns in this case are pretty much the same, which indicates that after a period of time, it really doesn't matter who started with the Frisbee. There's going to be just a probability that you have the Frisbee in your hand. Okay? That would be a horrible problem without the matrices. And you can adapt that situation to business situations and things like that. I've got a couple pages that summarize what I just said. I'm going to flash those up and get ready for the next segment.